To learn any technology, we have to get aware with certain tools and framework to have a good and a smooth learning experience on that technology. Same way, in the case of microcontrollers, we would group these frameworks and tools in two sets. First is hardware development kit and second is software development kit. So now we are going to delve into these two topics one by one, and we will at first start with the hardware development kit and then followed by the software development kit topic. Hardware development kit in microcontroller technology is a collection of embedded hardware tools and accessories to assist the embedded developers to design and prototype their product or learnings using the microcontroller technology. Now, before going into in detail about hardware development kit, let's get into the question, why do we need an hardware development kit? Microcontrollers are standalone integrated chips that require power to operate and have very small pins, and these pins are so small that it is very much impractical to connect these pins with outside world like other semiconductor chips or embedded connectors for doing the connections multiple times. And how big are these pins of microcontrollers are dependent upon the package type of a microcontroller that we have get to know in the last video of microcontroller technology. There are different packages in microcontrollers like BGA, LFQP, DIP, etc. And in some packages like BGA, the pin of a microcontroller is as small as a dot size. To make these microcontrollers usable, certain circuits and interfaces must be built around them. Like, consider the most famous microcontroller chip Atmega 328, which is there in Arduino Uno boards. The MCU is in LFQP package and which has pins coming out of it, and these pins are of very small length, and we can't make different connections easily directly from the microcontroller pins. Consider another packaging of MCU of BGA packaging, which has pins as small as of dot size. We can't practically connect multiple connections with this microcontroller pins easily. So we need to trace out the electrical parts from these pins of the microcontroller, as these pins of microcontroller are either in the form of dot or on very small length, and connect these electrical parts to some connectors like male headers, female headers, or other type of connectors to make the external connections with the microcontrollers. For that, just as we humans need food and water to power us, to survive us, microcontrollers also need a constant power source and electric circuit to function and to survive. And these power sources are provided to the microcontrollers typically from DC voltages of plus 5 or plus 3.3 voltages. Another thing, as mentioned in my previous video of microcontroller technology, that microcontrollers must be programmed for their intended function through embedded software of firm development, and this involves writing a code on a laptop or a desktop computer and transferring it to the microcontroller memory for execution using a hardware device called a programmer or debuggers. And programmers and debuggers are also used for troubleshooting and analyzing the program's performance line by line, which is dumped inside the microcontroller. So with the microcontroller, there is a circuitry needed of these programmers and debuggers also, so as to flash the firmware, the programming part, the software part into the microcontrollers and analyze that program. Without them, the programming of the microcontrollers can't be performed, and it's not possible. Thus, with microcontrollers, additional electric circuits like of power circuits, oscillator and reset circuits, programmer and debugger circuits, circuits for using its pins and an electrical trace out part and connecting them with connectors and headers, and all these miscellaneous components and formation form the different kind of hardware boards and hardware tools and accessories with the microcontroller, which leads to the creation of hardware development kit. Now, so in hardware development kit of microcontrollers, we can divide all these things in different hardware boards and tools, and these are: first, development boards or evaluation boards; second, debuggers and programmers; third, miscellaneous hardware tools; fourth, sensors and module breakout boards; and fifth, cables and connectors and other necessary connecting things of the microcontroller. Now let's get into each of these one and that wraps up this video in our microcontroller technology series. If you're ready to take your microcontroller skills to the next level, don't forget to save this playlist of what is microcontroller technology, as in this playlist over time time, you will find number of videos which will help you learn about these tips in chronological and interactive way by covering modern day industry level concepts, tools and technologies so as to become a skilled engineer and not just a graduated one. For viewers who wanted to expand their knowledge by hands-on practical learning, check out our Introduction to Microcontroller Technology course 101 built around the industrial grade NXP S32K144 microcontroller. This course dives deep into peripheral of modern day microcontrollers, teaching you real world tools and techniques and no more just theory. Head over to edu.gettobyte.com to learn more and get started. Let's keep learning, innovating and building together because a skilled engineer standouts, not just a graduated one. If you are new here, don't forget to subscribe for more in-depth tutorials and series videos. Hit the bell icon so you don't miss out our next videos and explore the next video so as to continue your learning in a chronological way from here and explore the full series playlist linked right here. Got any questions or ideas? Drop them in the comments below. We would love to hear from you.